Okay, so you had a couple more multiple choice questions left on this sheet. You just really had this last section. Okay, so it says, based on your answers to questions 15 to 19 on the diagram below, which represents a car of mass 1,000 kilograms traveling around a horizontal circular path of radius 200 meters at a constant speed of 20 meters per second. When the car is in the position shown, the direction of the centripetal acceleration. Centripetal, remember centripetal means center seeking. So it's always acting towards the center. So at the position shown, towards the center would be towards point C, which is choice 3. Number 14. The magnitude of the centripetal force acting on the car is closest to. Well, we have an M and V and an R, so do mv squared over R. So 1,000 times 20 squared, so 1,000 times 400 divided by 200. 400 over 200 is 2. 1,000 times 2 should be 2,000. That should be choice 3. Number 17. If the speed of the car were doubled, the centripetal acceleration would do what? So AC is equal to V squared over R. If I double the speed, that doubled gets squared, right? So if I make speed bigger, AC should get bigger. But because of the squared, if I double V, AC should get bigger by a factor of 4. So in this question it says, if the speed of the car were doubled, the centripetal acceleration would be 4 times as great, choice 4. Number 18 and 19 only have 3 choices, so don't pick choice 4. If additional passengers were riding in the car at the original speed, the car's centripetal acceleration would do what? So if there were more people in this car, then the mass would be bigger. So what happens to the centripetal acceleration? Well, if you look at the equation, there's no mass in the centripetal acceleration, so nothing should happen. The centripetal acceleration would be the same. The force would have to get bigger to keep it going at the same speed, but the centripetal acceleration wouldn't change. So 18 would be choice 3, the same. As the car moves from the present position to position X, what happens to its kinetic energy? So it's traveling at 20 meters per second. So at position A or position X, that speed hasn't changed. Its mass is still 1,000 kilograms. And so at no matter where it is in that circle, its kinetic energy should be the same. Okay, so again, the same, it doesn't change. So that's it for the multiple choice. And then the last 2 I asked you to do were on page 571, numbers 26 and 27. So number 26 is a motorcycle dude who he's a stunt rider and he wants to do a loop-de-loop within a vertical circle, right? So he's inside this, and so at some point he will be up here hanging upside down. Okay, so here he is. The radius of the circular track is 10 meters, so R is 10 meters, and it wants to know what minimum speed must the motorcyclist maintain to stay on the track. So when he's hanging upside down, and that's the thing of his motorcycle. When he's hanging upside down, Fg is acting down and Fn is acting down. And so the centripetal force, or the sum of the forces, will be equal to mv squared over r. It'll be Fg plus Fn, because they're both acting towards the center. Okay, so now it says minimum speed. So he's going to drop his speed, which means the right-hand side here is going to get tinier. And if the right-hand side gets tinier and he wants to stay in the loop, then the left-hand side has to get tinier. And Fg can't change. He's not changing his weight. So as the speed gets smaller, it's the Fn that has to get smaller. So he slows down, he slows down, he slows down. Fn gets tinier and tinier and tinier, so the two sides stay equal and he stays in the circle. And there will be some speed, the minimum speed, where Fn will go to 0. If he goes any slower than that speed, then the right-hand side will be smaller than the left-hand side. The weight can't change, and so the pull downward will win and he'll fall. So the minimum speed is when Fn is 0 and Fg or mg is equal to mv squared over r. The m's will cancel, multiply both sides by r. So v squared is equal to g times r, 9.81 meters per second squared, times 10 meters. Take the square root of 981, and you should get something like 9.9 meters per second. Okay, so not a difficult question if you understand what's going on. And what's going on here is as he slows down, the force that the track's putting on the bike gets less and less. All right, number 27 is our good friend, our good buddy, the Typhoon ride. Okay, so you're standing here on the side. Fn is going in towards the middle. Fg is acting downward. And friction is acting up. So it says an amusement park ride consists of a large cylinder, there we go, that rotates around a vertical axis. People stand on the ledge inside. When the rotational speed is high enough, the ledge drops away and the people stick to the wall. If the period of rotation is 2.5 seconds and the radius is 2.5 meters, what is the minimum coefficient of friction required to keep the riders from sliding down? So t, the period, is 2.5 seconds, and r, the radius, is 2.5 meters. From this, we can find the speed, because remember, v equals 2 pi r over t, because he's going in a circle. So once around is 2 pi r, and the time for once around is t. So 2 pi times 2.5 meters over 2.5 seconds. I would probably write it just as 2 pi meters per second. But you could do 3.14, 159, etc. if you want. But I'd probably leave it like this for now. All right? And it's wanting mu. So then do your sum of the forces. So sum of the forces in the y direction will equal 0, because he wants to stick on the wall and not slide. So friction minus Fg should equal 0. So FFR should equal mg, right? And then if you did sum of, you can't find those because you don't have m. Sum of the forces in the x direction should be equal to mv squared over r. So it'll be the normal force is equal to mv squared over r. And I'd be pretty tempted to take this and plug it in down here where we have FFR, which is mu Fn, is equal to mg. Okay, so then it would be mu brackets mv squared over r equals mg. The m's will cancel, and you're looking for mu, so multiply by r and divide by v squared. So mu is equal to gr over v squared. So 9.81 meters per second squared, 2.5 meters divided by our 2 pi meters per second squared. And when you do all this, you should get a mu of 0.621. Okay? All right, so I'm not going to do anything new today. I want you to work on your circular motion assignment. Tomorrow we're going to move circular motion to planets. But before I do that, I want to give you a chance to get a few of the circular motion questions done. All right, so there's no new videos for that. Just work on that circular motion practice assignment, and tomorrow we'll move to still circular motion, but with planets and the sun and satellites and stuff. Okay?